Chair of the Department of Food, Agricultural, and Biological Engineering at Ohio State. I have Sarah Moser from Savion joining me today. We're going to have to do a little bit of business, and we'll come back and I'll do a little bit more formal introduction, Sarah. Today's program is part of a series of Front Porch Chats, which are casual conversations between Ohio State researchers and external experts on sustainability topics that are relevant for many of the communities the university serves, including agriculture. The Front Porch Chat series has been organized by the Sustainability Institute to highlight key sustainability issues in Ohio and beyond in the weeks leading up to Earth Day. I would also like to give a special welcome to those of you who are participating in the Sustainability Institute's Passport to Earth Day. By joining today's discussion, you'll receive another entry to win one of Earth Day prizes offered by the Institute. Please be sure to register for the Sustainability Institute's website for the final Front Porch Chat on public health and climate that will be held at this time on April 16th. I'm going to set the stage for our conversation by taking a few minutes to cover basics about the practice of agrivoltaics, including the considerations that have to be factored into projects. I'm then going to introduce our external guest, Sarah Moser from Savion, and we're going to explore opportunities for farmers in Ohio and beyond in more detail. So, having said all that, since I got the business out of the way, we'll go ahead and move on here. Agrivoltaics, it means a lot of different things to a lot of different people. There's also another term that's pretty popular, especially within the Department of Energy, and that is dual use. And what we're talking about is other ways of leveraging solar farms, if you will, to do more than just produce electricity. And so we're going to cover today some of the opportunities that exist. Research has been going on probably for about 10 to 15 years in this area of agrivoltaics. But we have what I consider to be one of the nation's leading experts in this area, Sarah Moser, with us today. Sarah, could you introduce yourself and give us a little bit more about your background and tell us how you got to where you're at today?
Oh boy, that's a lot. My name is Sarah Moser. I'm the Director of Farming Operations and Agrivoltaics at Savion. Savion's a utility scale solar developer. How did I find myself here? Well, I was in the Air Force, come home to farm in Van Wert, Ohio, actually started doing economic development with OSU Extension, and a wind farm was built. And a second wind company came to town and they wanted to build a wind project. And they said, how do we do it better than the other guys? And I said, hire a farmer, get somebody out there who understands the compaction, the tiling, the way they're putting in their roads and how they're creating more end rows and making it challenging for us. And they offered me a job. So I left economic development and I went in to work for wind for about 3.5 years. Wind is... it had a bit of a challenge in Ohio. People don't like the height of them. The setbacks was an issue. They kind of shut wind down. And around that same time, Savion came and said, would you do solar? And I said, absolutely not. I can't farm around solar, right? And it was actually my father that convinced me that, hey, these solar leases are paying pretty good. You don't have to put it on all of your ground. You can just put it on some of your ground, look at the payoff. And I kind of considered it, but I told Savion that I'm like, nah, I don't know if I like solar, right? And they said, figure it out. Figure out how to farm it, figure out how it works with farming. And so that's kind of been my passion for the last 6 years with Savion, is to put the two things together, and have them coexist. So from, Northwest Ohio, farming with my family farm about 1,500 acres, corn, wheat, and soybeans. We put up a livestock operation about 9 years ago. So, a bunch of hogs, kind of how it all ties together. And I will tell you, I'm an operator, I'm not doing all the maintenance and stuff on the farm. I'm driving the tractor, but yeah, I that's where I come from. That's why I'm doing this. And I'm glad I found Ohio State.
Well, Sarah, we definitely enjoyed working with you on this most recent project, and we'll be able to explore that a little bit more as we go along today. definition definition of agrivoltaics, and I've seen a lot of them on the internet. There are a lot of different things included. I know the research has been going on within a lot of universities, various research institutes. Talk a little bit about, if you will, what your definition of agrivoltaics is, what it includes, what it may not include, if that makes sense.
Oh, so you bring up a very good point that the chasing the definition has been a lot of the problem or the challenge around establishing agrivoltaics. I know, both of us are working with ASABE for to come up with a standardized definition, and they've, joined with SEIA. I think, a year ago we were all on a call, or maybe it's been longer now, where, they were like, have you heard of this SEIA? And, of course, in the solar industry, SEIA is the, one of the bigger trade associations. And I'm like, yeah, SEIA, everybody knows SEIA, but the farmers don't know SEIA, right? And they weren't aware. And so I love that ASABE is helping put this together. American Farmland Trust has done a lot of work on a definition surrounding, agrivoltaics, and really what it is to me is this concept of agriculture leading the transition to renewable energy. So I've said it many times, let the farmer figure it out. Let the farmer drive what they need with their ground, what they think is best. Some farmers decide to grow soybeans and others want to raise sheep, or they want to raise beef, or they want to grow canola oil, canola, and make oil. Like, there's just so many different facets that come to farming, and the farmer knows their ground the best. They know if it's wet, they know the soil, they know what grows, they know the seasons. And so I feel like agrivoltaics is really that dual use of saying what makes the most sense for this piece of ground, and how do we continue to be those land stewards that farmers are, right? And to me, that's what agrivoltaics is. And I think we're seeing it go that way. And a lot of people are just trying to put standards behind it and beside it, and what works. But I mean, and what your position is with the precision ag, we're seeing that as equipment is changing, it just opens the possibilities. And I think we're going to talk about that a little bit later. So agrivoltaics is kind of a moving target, which is exciting, right? So
Yeah, so Sarah, you mentioned ASABE, and the audience may not be quite so familiar with that organization. It is a professional organization, the American Society of Agricultural and Biological Engineers. And as you well know, one of the first things you do when you start any kind of standards work is you develop definitions. And that's the mode we're in right now, because this is such a new area and a rapidly evolving area. One of the things I'm often struck by are perceptions of, especially the public, about what a solar farm looks like. And so I was wondering if you could talk a little bit about what has become kind of traditional in most of the solar farms that we hear about in terms of construction techniques. There's a lot of things that go on because you got to collect the energy that's being produced and obviously get it to the grid. And we know and understand all that. But kind of take us down the road about some of the challenges when it comes to farming between panels, the solar panels, if you will, given the current construction techniques. And then maybe lead us down the road in terms of what Savion has done to investigate this area of agrivoltaics.
Well, I would offer that probably the biggest challenge and it is scale right now. And I mentioned, Savion is utility scale. So I was on I don't know, a webinar a week ago or whatever, and they said there's like 600 agrivoltaic projects that are like registered with the country, but they're all under, 1 megawatt or under 5 acres. And so really the agrivoltaics challenge that we have, I mean, everybody can have a big garden in a community solar project where you can do these labor intensive practices of hand tilling and, going out and planting tomato plants or doing produce and specialty crops. But when you're talking about projects that are, 750 acres or 1,000 acres or more, you really have to solve to scale. And so, that was an interesting piece with Ohio State's pitch for forage crop. Hay and alfalfa is something we could grow at scale. Soybeans we're seeing will work at scale on a solar farm. But the challenges then become is what works, with the system. So we're not shading the panels. So if your corn gets too tall or you're too close to the panels, you're going to shade them and lose resource, because the solar company's prime priority is producing power. It's not growing crops, right? And then the farmers the other way around and the opposite. So you've got to mesh those two together and figure out how you hit that sweet spot of being able to do things at scale. The engineering changes or modifications that need to be made. In Ohio, it's not a lot. I will say that the way solar projects look across the country will change depending on your latitude and your topography. Different things will drive how high your panels are, how close together they are. Some of them almost lay on the ground. The systems here in Ohio have gone to the tracking systems. They're not fixed, which allows us a little bit of latitude when it comes to, moving between the rows. Um, the EPC, so your engineering, procurement, construction companies have come down to trying to get them built fast. So they've taken things out of where, originally they were burying the cable. Now they've got a system where they hang them and they can go faster. So we really need to get that obstruction out of the alleyway. So burying that cable, putting it underground so we can drive over it with our tractors. Like I said, spacing kind of works in Ohio. We've got about 17 feet leading edge to trailing edge when the table, they're laying flat. But as they get closer together, because you've got to squeeze more panels into an area, you might go down to 10 or 13 feet, which, again, ag equipment, we can design it in a way that we try to fit those slots. Really preserving the topsoil as we go through construction. So we're trying to teach construction companies how to, think like farmers. So we've got to preserve that topsoil. We've got to think about drainage. In the Midwest, drainage is a big deal. And so all of those piles are going in and they're destroying laterals. We have to rerun tile, or we have to repair tile, and we have to find ways that the site is going to drain so that we can farm it or even mow it, right? I don't know, there's a lot of challenges, but it's nothing huge to get past, right? Like they're all little tweaks that can be made if you can get into the design um, conversation early on. You're able to mitigate a lot of that. And, I've heard a lot about raising panels higher so we can drive underneath them. A lot of people have seen pictures of Europe, and those I would offer are smaller installations, but also steel's expensive. So every, 6 inches you're raising that steel, it's, tens of millions of dollars, and that's a lot of cost that solar project margins won't carry. So we have to figure out a different solution versus just raising them up higher.
Yeah, and Sarah, one of the things to that point that you just made, oftentimes the solar panels are mounted on piers or steel I-beams driven in the ground. And what you're talking about is when you make those I-beams longer, obviously that increases the cost of the solar farm, at least the capital cost. One of the other things that a lot of people tell me when I talk about agrivoltaics, they look at me and they go, well, Scott, you can't raise crops under there because there's no sunlight. And so I'm kind of curious what your response to that is, or how would you advise people to think about agrivoltaics? Because after all, it's the sunlight that causes the plant to fix carbon through photosynthesis and creates the grain or the biomass that we value in one form or another.
Well, a couple things come to mind. I know one, you point out to people, we've got a picture with the 20-foot drill going down through when the panels are angled, and there's a lot more sunlight than you think. So there is shaded area, but with the trackers, that shaded area is kind of distributed, and the sun comes when it needs to come. The shade is actually acting as protection from these hot, drought Julys that we had, like last year. The items in the shade actually were growing better. because they were still getting enough sun, but they weren't getting that direct heat when there wasn't the water there for them. So, and that's part of the research that we were able to do with Ohio State, is like things did grow in the shade. Alfalfa is a full sun crop, and it grew actually more diverse and better in that shade strip. You could see how green it was when the sun wasn't burning through and making areas basically for weeds to come up. The crops did better. So I think it goes back to the challenge that the farmer has with what grows best, right? And give it a try. See if you don't like the yields you're getting, then maybe we switch crops, But from what we've seen so far, everything kind of likes the shade. And I've heard we have a big meeting we go to. It was in May or June, and then now it's in August this year. It's called the Solar Farm Summit. And Dan French, who runs that, he says, shade is the superpower of solar. And what we're finding is it really is that things are growing. Sheep are laying under the panels. It's cool. I know when we're out working on the site in the summertime, we stand underneath the panels. It's cooler there. We're protected from the shade, right? So that's one part of it. And I've heard you talk about it before, is that, farming is using the sun through the plant to make the yield and produce the crop, etc. Solar is doing that directly, right? So, and if we're doing dual use, we're able to produce double yield because we're creating energy directly the most efficient possible way. And then we're also creating crops in those alleyways and beside it. So,
Yeah, and to that, we've seen a lot of these studies, and the bottom line is it's kind of crop specific in terms of what that crop's response is going to be. But I'm also reminded that basic agronomics still apply. Soil fertility, moisture availability of the plant. There's a lot of things that are very similar, whether you're growing a grain crop out in the open or whether you're growing a grain crop under solar panels. Part of the challenge, though, and I think you alluded to this, is we're probably not going to use 60-foot wide planters, are we?
no 40-foot draper heads not going through for harvest.
Yeah, so some of the challenges we have obviously is navigating between the solar panels and still maintaining, I'm going to say, agronomic practices that are beneficial for crop production. And again, smaller equipment. As we kind of think about the future in some respects, when we think about small equipment, are we going to have operators on the equipment? Is that going to change in some manner?
I know that's your sweet spot, right? Is like talking autonomous equipment, and my kids love it. Drones, robots. So you still need an operator. It's just not your traditional, hard work out there sweating in the dirt, and it's running and controlling something to navigate the alleyways. But also, a lot of the equipment that we've used out on site has been the smaller farmers, the ones that have 200 acres and are keeping smaller equipment in their barn. And that, to me, is an exciting opportunity for first-time farmers. They don't have to use that major investment to go out and buy $1 million piece of equipment. They can pick up something at an auction that's a little smaller equipment that the big guy decided to, let go of, and use it, to get started on basically land that we're going to let them use to go in and farm. So, there's all kinds of ways to look at it. It's future, where's the precision ag going to go? But it's also the past of bringing in those roots and those ways that we've always farmed before we got so big. So
Sarah, I know that you had some plots up in Northwest Ohio where you had limited, I'm going to say, study area, so to speak. Now here in Central Ohio, there's an opportunity to do things at scale a little bit more because of capabilities that Savion has created. How would you characterize your experience to date with agrivoltaics, both from your experience in Northwest Ohio and then what's going on in Central Ohio now?
Oh, um, I think there was probably a lot of things that we didn't think of. I think from seeing, the community scale, the smaller installations, you think it's going to be easy. But, for instance, I think we had to, mow the hay plots. We mechanically controlled the weeds, right? So we went out and mowed. It was, 32 acres of mowing. That's a lot of mowing, right? That's a lot of wear and tear on your equipment. That's a lot of man hours. So realizing that scalability is that's the first challenge I guess that I brought up. It doesn't hit you how big it is until you're out there and you're thinking, oh my gosh, we've got to spray this all with a gator, right? And how long that's going to take. So, and I completely understand why farming has gone to the bigger equipment, because we are cutting down that farm time. We're doing that, right? So I think that's probably the biggest thing that hit me, that it wasn't as easy as we thought it was going to be, to just, oh yeah, we'll just go out and plant something. And not because of the constraints, but more just because of the size. You heard me say our family farm is 1,500 acres. In one site, I'm farming more on that site than my dad built over 50 years, right? Like that's crazy to me. But it's also such a neat opportunity, because like we're talking first time farmers, giving people the access to get in and do this. It really allows us, kind of low hanging fruit, to reinvent farming, or introduce and invite people into this amazing, lifestyle and way of life that comes with working with the ground.
So I'm kind of wondering, and I know that things are really just kind of getting started at utility scale, if you will. I know there's a lot of developers that are interested in this type of thing, but look in your crystal ball, if you would, a little bit, and tell me who's going to be farming these sites, what the relationship might look like with the developer or the solar farm operator. What do you see as, I'm going to say, the possibilities, if you will? And I know that the business practices will evolve over time, but I also know that on these existing solar farms, absent agrivoltaics, they do have some vegetation management challenges as well.
Mhm. I think every site's going to be different. I feel like, and this is probably getting into a sidebar for me, but like everything has gotten so corporate, right? And I feel like I would like to avoid that, where I know there's, risk management in that a bit. There's also the concept of, the local communities. It's the regional knowledge, it's the experience that you have with the land, that I think is going to play well into community engagement, community benefits, community development. And so, in some cases the Savion owns the land. In some cases we lease the land. So everything is going to look a little bit different based on who's your landowner. What's your team on the ground? How many projects do you have in an area? If you have a couple that are within an hour, you might have one person be able to handle it, or one crew kind of thing. But I feel like the opportunity is there, for anyone that's willing right now, is and I see there's such an entrepreneurial, concept behind it, because people come up to me all the time, how are you going to wash all those panels, how are you going to weed whack around the piles, how are you going to do this? And I'm like, I haven't thought of that. But they have ideas, and it goes back to farmers figuring it out. We've been fabricating equipment since we were born, right? That's what kids do. They build stuff in the barnyard. So I think that what we're going to see is a relationship with the communities that we're in, um, and figuring out the best solution for each one.
So I've been surprised, in terms of um, a lot of the things that I've experienced, on the particular site that we've been on. I continue to be amazed by the reactions of people that are brought to the site to tour the site. And, they kind of have one concept in mind. And then when they get to the site, they kind of change a little bit in terms of their perspective on things. One of the things I'm continually kind of amazed by is when they're thinking about agrivoltaics and they're thinking about farming, that they probably miss the scope and scale of what's going on when you look at a solar farm. I think that they may discount that there's really tremendous opportunity there, but it comes with some challenges they may not be used to. And I think people going into it with a mindset that, this is traditional production agriculture in the state of Ohio, they need to adjust that a little bit. And, we begin thinking about how we're going to move whatever's produced out of the site as well. Kind of walk us through a little bit about what some of the concerns might be for people who would be interested in something like this. In other words, there are some safety concerns. I don't think there's any question about that. But kind of talk through a little bit, if you're grazing animals or you're going to be operating machinery, what are some of the things that you have to be sensitive to in terms of a partnership with a solar farm operator?
Well, I feel like grazing is one that I would touch on. The goal is not to go out there and just have them eat everything down to the bare. I mean, we're still looking at uh, not overgrazing, of grazing right, of having healthy vegetation, of having healthy livestock out there. So it's not just a haphazard, oh, I'm going to release my sheep or release my animals out there and let them just eat all the grass. There's a lot more planning and thought and rotational great, like concepts that go into it. Same way with farming. We have an O&M team that is working on maintenance on the site, and something that was brought up is like, well, now we drive our trucks down and we do the maintenance and do our spot checks. Well, if we have a crop growing there, we can't walk on it, right? We have to walk on it. We can't drive on it, right? Like, so they're like, oh, we don't want to drive over your soybeans, or we don't want to drive over your plants. So it really, we have to remember that, like, the power production is happening and there's other people there that have to do their job, which I feels like maybe hard for some farmers because we're our own bosses as farmers, right? And we don't want to work with anyone else's schedule. We don't want to say, oh, well, now's the time we got to go. Now's the time we make hay or whatever. And so I think that's part of the understanding. If you're coming into a solar site, the solar site's concept of productivity is the power and the production there, and the farmer's concept is like, I gotta make yield, so I gotta get it planted exactly on this date or in this time and have those things. So we have to work around each other's schedules, and we have to make sure that we're planning in a way that's complementary to both practices. So that's probably the biggest thing. I mean, safety is always a major concern. Just, making sure that you're not careless out there. I mean, what farming's the most dangerous occupation, I think, just because we do things the fastest way, or sometimes cut corners as farmers, right? I remember my dad had an old broomstick that he would use in the auger when we were sweeping the bin, and it just was gnarly, right? It got mangled because it was the easiest thing to grab. Well, we have to get away from those practices because we are working inside of someone else's house to get the farming done. So I think those are things that as farmers we have to kind of learn to walk a little bit of a protocol or something. So that's a way we have to change a little bit.
So I've been asking Sarah a lot of questions, and I'm certain there are a number of people that have joined this event that may have questions. I encourage you to put those in the chat, and we'll make certain that Sarah has an opportunity to respond to them. I always enjoy my conversations with Sarah. I always learn something of value. And, the I see tremendous opportunities, but I also see that we're going to have to do things slightly differently than we've done in the past. And um, I've enjoyed the opportunity to think through what some of the equipment complements look like. The one that still has me a bit perplexed, Sarah, and maybe you figured this out, but if we're producing grain between those solar panels, whether it be wheat or soybeans or something else, I'm still thinking about how we get that out of the solar farm. We've traditionally in agriculture, we use big grain carts and big combines and everything. And certainly the combines will be smaller, but I'm also thinking, how do we move that grain out from between those rows of panels and get it out to a road where we can load a truck or something like that and move it off site? I'm also thinking about the same thing with some of the forage production and thinking about how we might be able to move that as a product to the marketplace.
Yeah, well, and you've seen a lot of pictures with, the auger that extends over one row to the next row, and you drive your grain cart down one row beside a combine that has an auger out, that's a possibility. We had, well, the Ohio State combine out there that has the auger that can dump behind the combine, directly behind it, and you follow it up with a grain cart or a hopper wagon. We do have the access roads along the site. We can park semis, we can come around and dump, we can, those kind of things. I think the forage crop is going to be interesting. That's one thing I tell people is that it's not so solid solar panels. There are open areas. We've got a 15-foot circle that doesn't have any panels in the middle of the fence. We have a 64-foot strip where we avoided, a main tile or had an old wood, like things. So there's areas on the site where you can stack and store bales of hay or alfalfa. And I think that brings up a good point, and you touched on it a little bit earlier, that like the transportation, the market that comes around each of these projects, it's not just the farming part, it's going to be the trucking part, it's going to be, where are we putting the crop, or where are we taking the livestock, where are we housing them in the winter, and so there really is an agribusiness community that can surround each project and help solve to some of these things that you're talking about.
Yeah, and so one of the questions we received in chat, Sarah, was how cost effective is this technology compared to conventional? And what are the things that might be more or less expensive? So
My first question is compared to conventional solar or compared to conventional farming?
I think conventional farming would be the first thing
Right.
to address.
And so my thought with that, and I can give, the analogy. We have a gentleman that lives next to us in Van Wert that has 14 wind turbines on his property. We call it mailbox money. He doesn't have to put a thing in the ground. He doesn't have to harvest anything, and he makes X amount of money for just walking to the mailbox. So if a conventional farming operation puts solar on their land, the margin that they get from that mailbox money, just leasing that land or selling that land to the solar company, is pretty good. I mean, that's pretty good money, right? And then now farming in between the rows, your yields might be a little less, or I mean, technically what we're getting is about 70% of the land area, right? 30% is taken up for equipment. 70% of the area you can still farm. And our yields were pretty decent last year with our soybeans, from even with a drought. I think we got, 35, 40 bushel an acre. So they were as good as double crop. And that's money on top of what, was being leased, if we, depending on how the contracts are stacked, right? So I would say on the conventional side, I mean, is it going to add up to somebody that's just straight out farming 1,000 acres, with a large equipment? Maybe not yield wise, but I think income wise and revenue wise, it absolutely could, depending on where the solar lease money is going to, off the top. I see it as supplemental income, so I think that it actually is additive to conventional farming styles. So, and as far as solar goes, solar is leaving the money on the table. They're doing nothing with the ground, right? So for them, it's additive as well, right? It's something where it's like, hey, you can either reduce costs by not mowing everything and letting the farmer do it, or if you decide to farm it yourself, you're making that land value back in crop production. So I think for both of them to be additive.
Yeah, one thing I got to correct, I might have said to the audience, place your questions in chat. I probably should have said, put your questions in the Q&A section. So I apologize for that. And if there's any confusion there. Sarah, what do you see right now as in terms of agrivoltaics as being some of the most likely scenarios? In other words, we've talked a little bit about animal production. We've talked about the possibility of grazing animals under the solar panels. We've talked about the possibilities of producing grain, producing, if you will, forages. Where do you think things are going to kind of settle out as this kind of matures in terms of the first crops that I'm going to say get kind of a foothold, whether it be animals, whether it be plants? What do you think we're going to see coming out of solar farms where agrivoltaic practices are being adopted?
Well, if I had my choice right now, I'm really liking the alfalfa. It grew really well. It did really well, established well. I think we need to go through a harvest season for it to see how that all kind of pans out as far as, baling it, cutting it, baling it and whatnot. And how we're moving bales to the end and what we're doing with the bales. But I love soybeans. And I feel like the soybeans have done really well. I like planting them on just the farm in general. I think they're a hardy crop. I think they do well in Ohio. We planted some corn, and it worked really well in your, I think we had 6 rows of corn, right? So it didn't shade the panels at all. And we're talking about potentially doing 8 on the site this year. Corn works. I think that we're probably going to have rotations, right? Like, so if you're talking 1,000 acres, you could do, 500 acres in one and then you're rotating your crops the same way that you're doing in the field. There's definitely a value to forage crops because we're not, having to replant every year. But you'll have multiple cuttings, so you'll be in there more often doing the cuttings. So I think there's, I don't know. I think it's going to be in those 3 crops probably that we're going to see the most. But I'm also an Ohio girl, right? So I've had people talking to me about cotton and talking to me about other crops that maybe I haven't considered as much. I think the farmer needs to decide. I think the region needs to decide. Sheep has been a very a possible and kind of an easy low hang, like it was something transitionally easier maybe to do. I've heard people say, they don't want the sheep, they want beef instead, which cows are a little more cantankerous, a little more difficult to put out there on the site. They're bigger than what sheep are. But I think you're going to see sheep be a solution that's used a lot as well. And I think we're going to kind of change the sheep market and bring some of that back to the US. So that's a good thing.
Yeah, so one of the questions that was posed, what about industrial hemp?
Gosh, that's a great question. I'd like to try it and see how it grows. I really would. I think that that's definitely something that you're seeing, value in industrial hemp. And I think we're going to see that one take off a lot for many qualities that it has. So that might be one. I mean, and then you're doing the bioenergy, the biofuels and the renewable energy together, and we can stay on that common theme. I think the market's going to drive it the same way it does with farming, right? You decide what you're going to grow based on where the market's at.
So, Sarah, I know that there is a strip of land that kind of coincides with where the piers are driven in the ground for holding the solar panels. you and I have talked about a lot of different possibilities there. What are some of the things you're thinking about where it's impractical maybe to plant a crop because of the mechanical impediments, if you will? What are you going to do with those strips of I'm going to say, I don't know, field surface area in between where we're cropping?
Right. So we're right now what we're looking at is pollinator habitat there. So a perennial grass, a wildflower mix. And this brings in your bees, right? So now we're helping the bee population, which helps our crops, which helps, the whole story. So I mean, picture a living ecosystem that is this whole solar site, right? Where things are complementing and working together um, to increase biodiversity and to improve the land. So, but that's what we're trying out at Madison Fields. Another project, Marion, we actually planted strips before we put the piles in. So now they're putting piles into those 6-foot strips of that perennial grass mix, that wildflower mix. And we'll see what comes up and go in and of course overseed where we need to. But I think it's really it's all kind of working together of the open space that we have.
The one thing, and you kind of touched on something I think is kind of important. When we think about agrivoltaics, what you're indicating to me is some of the construction practices are going to change. You mentioned that during the construction process, you were seeding some of the initial crops or some of the initial vegetation. Are there other considerations during the construction phase that you think might be important in the future?
I mentioned drain tile. Drain tile's been a challenge. The question is, when do you do the drain tile? How do you sequence it in a way that, you're not cutting brand new tile or you're not crushing brand new tile? What time is the right time to put it in? And I'd like to have some of your students come up with some solutions for that if they can, or, but, I think the topsoil, protecting the topsoil. So, the standard construction practice is just remove everything off so that you can work on it fast and the mud's not there during the rainy seasons and whatnot. And we've got to just make sure we're protecting that topsoil and separating it and not mixing it with the subsurface soil. Um, I think those are just the two basic things I think that we can do during construction. And I feel like I'm not asking a lot, right? Like, so I hope we can convince the construction teams, but understanding that their job is to get in there and get the project built and get moving. So we're trying not to, you know, I don't know, be too, you can farm about anything. I've seen, barns buried and now you're farming over it, right? Like I've seen lanes taken out and fence rows taken out. So I feel like if the farmer gets access to the site, there's a lot of things we can do. If we preserve the topsoil, if we think of the drainage stuff up front, that we can help, decompact the soil. We're working with cover crops. We're talking about soil health on the grant project we're doing with Ohio State. And so I think a lot of that, even like regenerative farming concepts, are going to come into play as we, I don't know, make the best farm we can have.
So I hear you addressing this issue of soil health. Seems
Mhm.
to be kind of front and center with a lot of Ohio farmers today. And I hear it again in terms of agrivoltaics. Um, one of the things that kind of struck me, Sarah, was it was a tough year this past year in Ohio because of less than adequate rainfall. But I was quite amazed by the quality of the alfalfa crop that was established. I also know it's a very deep-rooted plant and probably has a lot of positive benefits in terms of alleviating any of the compaction concerns. What's your take on that first year's experience in terms of cropping in Madison County specifically? And what's your general feeling about how successful or unsuccessful it was?
Uh, well, a lot of people said it won't work at all, right? A lot of people are of the opinion that, 'Solar projects go in, excuse me, and just, destroy the ground. There's no way anything will ever grow there again. And I think that that was the biggest success that we saw, is that it did grow, and it actually grew well and flourished in many areas of, in the site. Um, so I think that it's, as much as people want to say it won't work, we saw that it would, but we also saw that it wasn't easy, and that there's a lot of, runway yet to work on, and a lot of lessons learned, and a lot of improvement. And so I think that's the most exciting part for me. And that's what I saw the most in this year's, just the learning curve for us being out there and realizing how much possibility there was.
Yeah, and Sarah, I've been out there to that site with a number of tour groups, but one of the comments that I heard made by one of the tour groups, or one of the tour attendees, they looked towards the end of the season at the nature of the alfalfa crop that had been established, and they said, I'd take that anytime for a first year alfalfa crop. So that to me kind of validated in some respects the fact that it is under difficult circumstances, given the nature of the cropping season last year, that it is possible to establish forage crops. I know we had some forage crops that didn't do quite as well, but on the other hand, I was pretty pleasantly surprised at the end of the growing season in terms of what we were able to establish, and the overall quality. It'll be exciting, obviously, to begin getting yield data from those trials, but that's all part of it. Talk about the soybean crop that was grown out there. And I remember how this came about too, which I think is interesting as well. So,
and I think that was the part I was thinking just when you were saying that, is like, for the research side of the house, the researchers wanted to mow the soybeans, and me and my husband about lost our mind. We were like, no, this is a good soybean crop. Like, you're not going to just mow this for research, so it became a little bit of a little beef there between us, because um, the soybeans look really good. I mean, um, they were nice. And I think we had a group out, and there was some guys from Nebraska even, and I remember asking them, and they were like, man, these are really good soybeans. So that's where I say, like, I'm ready to plant soybeans on the whole site, right? Like, that's how I feel like they did really well. And that came, soybeans are nitrogen fixing. They were good for the ground. It was something we actually put in as just a cover crop on our research plot, and they were like, oh, it's time to plant something else, Sarah. And I was like, no, you're not cutting the soybeans, right? So yeah, I think we had a good crop of soybeans. I was glad we got to harvest them.
yeah, and I think the take-home message for me, originally it was put in as a cover crop in anticipation of seeding some fall crops, and then it actually went to harvest, and so it was a pleasant surprise when we looked at yields at the end. But again, it was also pretty amazing to see the faces of some of the people that were touring that site when they saw the soybeans growing between the rows. So Sarah, I'm going to ask you probably an unfair question, but what are the unknowns at this point in time? What are the things that there's been some successes? You have a vision for where things may be headed, but what are some of the unknowns? What are some of the things that I'm going to say keep you, well, that you want to know a little bit more about, and you may have concerns about in terms of agrivoltaics?
I think probably the biggest concern that I have is that, and I don't know, this might get into just more, conversation in general, but we haven't had a lot of time out there doing it. We know that accidents will happen. I mean, every farmer's hit a telephone pole with the auger, right? Like, if you haven't done it, you're going to do it. So I fear that first mistake, right? I fear that, somebody gets hurt or something happens, and that they decide agrivoltaics isn't worth it. And that's probably what my biggest concern is right now, is because we're still trying to convince them that it is worth it, and to have someone do it haphazardly, or not go through a process that's safe, or jump into it before it's scalable, and have it, crash and burn before, so you do have to put the time in and do it right and do it well and learn as you go and not jump all the way in with, both feet before you have a scalable, replicable process, right? So I don't know if that's what you were
No,
looking for or not, but yeah.
I think you're spot on. Sarah, I have one last question here, which is probably the best way to close this out of anything I've seen so far. And again, we had a lot of good questions. We couldn't get to them all today, and we'll apologize for that. But are there opportunities for student agricultural solar projects? In other words, what roles might the high schools and or technical schools play going forward?
Well, everyone needs to sign up for your class, right? Is that so? Um, but I mean, what we're trying to do out at this, first site that we're working on here is a lot of R&D. It's a lot of demonstration. It's a lot of figuring it out. And we have, like you've mentioned, we've got tours. So I think that, that's something that gets you out on site, get you excited about it, get you, really baking some of those ideas. But I think, you and I've even talked about capstone projects and ways to get students involved. There's so much opportunity and there's so many things that you and I haven't even thought about of ways we can go with it. That yes, there's absolutely projects, there's potential. I think FFAs and 4-H clubs coming out, just getting outside again and gardening, or working with the dirt is good for everyone. So I feel like that we're heading in that direction and we'll be able to make that connection with the projects.
Well, Sarah, I'm reminded of one last experience that you and I had. We had the Monarch tractor people come out, and I don't know if anybody listening is kind of aware of the Monarch tractor. It's an electric tractor out of California, but it's fully autonomous. Um, Remember what your experience was with the electric tractor, Sarah?
I do. If you all don't know what that is, the Monarch tractor is just fascinating, right? But I mean, this tractor drives itself. I mean, so you've got autonomous working. It has safety measures all the way around it. So it's going to stop if it sees a person, if it sees a panel. We're talking about having it talk to the trackers, right? And have ways that it's ready to go down a road, the trackers move for it, like just there's so much potential in technology and the things that they're doing. But yeah, I feel like, Monarch's a smaller tractor. It started, Vineyards, California. It's doing that row type design, and it's kind of built for this, right? So I feel like there's a lot of potential. I mean, and even John Deere, right? I don't want to discriminate against the different manufacturers. We went out and met with John Deere, right? And they're excited about it. Kubota's excited about it, right? Like we've got a lot of players that are seeing the future in this. And now we got to get the farmers on board because, they're really where the ideas come from.
Well, Sarah, I have the opportunity to talk with a lot of farmers in various venues, and I always bring up electric tractors, and they always look at me, well, Dr. Shearer, where are you going to plug that in? Well, I got my video from that day, and I always tell the farmers, I don't see a problem, do you? As the electric tractor moves between the solar panels. Well, Sarah, thank you very much for your time today. Very informative. Hey, I got a question for you. If people are interested in learning more, do you have any resources you might be able to share with them?
Oh boy. Well, the first thing I would say is come out to Madison Fields, right? Like, so that's my best resource is, there's a lot of resources if you Google agrivoltaics, you're going to find the Inspire website. You're going to find a bunch of different places, although I'm not sure if they continued Inspire, but they've got this Agri-Solar Clearinghouse. They've got different, places. Come to the Solar Farm Summit in Chicago in August. Look that one up, and really get involved with the people that are on the ground, the farmers that are doing this, the grazers that are doing this, and learn from experience. If you look to anything written by Alexis Pascaris, she's that'll be more your academic side, right? Your policy, getting into some of that information. She's done a lot of research on agrivoltaics and has a lot of good information through NREL and those organizations. For the farmers, for the doubters out there, I would have them watch the documentary Kiss the Ground on Netflix. It talks about large corporate farming and how we need to maybe get back down to some of this smaller design. And then I was supposed to think of books that would work, and completely off topic, not farming or agrivoltaics. There's a book called Grace in the Gray. And I would recommend people to read that, because this isn't really a black or white answer. It's not a one or another. It's dual use. It's working together. It's finding that compromise and that sweet spot of what's going to benefit both worlds of agriculture and renewable energy, and how we can move forward together for the best practices.
Well, Sarah, thanks again for your time today. I'll also remind a lot of people that the Department of Energy has quite a bit on agrivoltaics on their website, so another great resource as well. And I'm certain, Sarah, that if anybody reaches out to you, you'd be happy to provide them with more details on a number of those resources that you just shared with us.
Ohio State has some pretty good publications now as well. So
yes, we do, through the Cooperative Extension Service. So great point. Well, thank you, everybody, for your time today. Glad that you could join us for this conversation, and look forward to future events with Front Porch Chats and the Sustainability Institute. Thank you very much. Goodbye.